To solve problems in mechanics, one has to understand the concept of force diagrams. If one can draw the correct force diagram, then solving a problem simply boils down to writing equations for Newton's laws from the force diagrams. Now let us start by looking at some examples and understanding how to draw these force diagrams. Now before we do that, we need to understand the concept of weight. Now what is weight? The weight of a body is actually a force. The weight of a body is a force that is exerted by the earth on the body. Now, as we start looking at some of these examples, we will know how to draw the weight of the body and in what direction we need to draw it. So let us start by looking at a block that is placed on a table and that is at rest. Now, this block has the force exerted by the earth acting on it in a direction that is vertically downwards. Now, that force is what we call weight, and it acts vertically downwards and is denoted by the letter W. Now, this force is the force exerted by the earth on the block. Now, if this is the only force acting on the block, then this block should start moving down. This block should start accelerating down according to Newton's laws. Now, since that is not happening, since the block is at rest when placed on the table, there should be something that is preventing the block from accelerating. There should be a force that is preventing the block from accelerating downwards. Now, where can this force come from? Now, this force should originate from an object that is preventing the block from moving down. Now, the only object that can prevent the block from moving down is the table. Now, if we magically remove the table, then the block would fall down. We all know that. So it is the table that is preventing the block from moving down, which means that the table should exert a force that is equal in magnitude and opposite in direction to the force W, or opposite in direction to the weight of the block. And that force, which is exerted by the table on the block, is what we call normal reaction. Now, this force W is the force exerted by the earth on the block. This force N is the force exerted by the table on the block. Now, since the block is at rest, according to Newton's laws, N should be equal to W. Now let us consider another case. Let us consider a case where a block is being suspended from a string which is tied to the ceiling. Now this block is also at rest. Now to draw force diagrams here, I'm going to separate the block out. Instead of drawing the force diagram, instead of drawing all the forces acting on this block in this diagram, I'm going to separate the block out. So if I separate the block out and start looking at forces acting on this block, we know that the earth exerts a force equal to the weight acting on the block, acting vertically downwards, denoted by the letter W. Now, just like the previous case, if this was the only force acting on the block should move down. And since this is not happening, the block is being prevented from moving down. The only object that can do that can prevent the block from moving down is the string, because the block is tied to the string. So there should be a force, there should be another force that is exerted by the string on the block. Now that force should act vertically upwards and should be equal in magnitude to the weight. And that force is called tension and is denoted by the letter T. Now, according to Newton's laws, since this block is at rest, T should be equal to W. Now, we have drawn all forces acting on this block. W is the force exerted by the earth on the block. T is the force exerted by the string on the block. And these two are equal in magnitude and opposite in direction. And this completes the force diagram for this block. But now we can go ahead and draw the force diagram for other objects in this system. Let us consider another object in this system, which is the string. Now, if you look at the string, so I'm going to draw the string here. Now, I have separated the string out from the system. Now, the top of the string is attached to the ceiling. The bottom of the string here is where the block is tied. Now, when you look at the string, we know that this force T should have an equal and opposite force according to Newton's third law. Now, this force T, which is the tension, is exerted by the string on the block. Now, according to Newton's third law, there should be an equal and opposite force exerted by the block on the string. Now, that force obviously should act at the bottom point because that is where the block is tied to the string. So that force acts vertically downwards and should be equal to T, because according to Newton's third law, this force should be equal in magnitude and opposite in direction to this force. So this force here, T, that is acting on the string, is being exerted by the block. Now, if this is the only force acting on the string, then we know that the string should start moving down because it has an unbalanced force acting on it. But since the string doesn't move, since the string is also at rest, there should be another force that is acting on the string that is preventing it from moving. Now, that force should come from the ceiling because it is the ceiling that is preventing the string from moving. If the ceiling were to be removed, or if the string were to be cut here, then both the string and the block would fall down. So the ceiling should exert a force that is equal in magnitude and opposite in direction to this force T. And that I'm going to draw here should be equal to T and should act vertically downwards. Now, even though I have used the same symbol for three different forces, one here, the other one here, and the third one here, so even though I have used the same symbol, these are different forces that are acting on different bodies exerted by other bodies. So this force, which we also call tension, acts on the body, on the block exerted by the string. Now, if this is the action, then according to Newton's third law, this is the reaction. So this T here is the reaction to this force. Now this force is exerted. So if I call this T1, if I call this T2 and T3, where T1 is equal to T2 is equal to T3. Now T2 is the action for T1, is the reaction for T1. So T1 and T2 are action-reaction pairs. Now T3 is exerted by the ceiling on the string. T3 balances the force T2, so the string is at rest.